Thank you. And we just have a small poll there saying who has experience working in the industry of security, uh, big data, or combination of both. Uh, so, so this one is the one that we can probably, yeah, this is also, we can do one, and then maybe another one is especially for today's uh, talk would be the cyber one. Okay, so all right, so is my screen visible?
Yes, it's visible. And sorry, I put up the tomorrow's poll. So here is the poll for today. Yes.
Yeah, so this is the right poll. Okay, thank you for bringing it up. So
Yes.
it's kind of like relates to today's talk, so it will be easier. So let me minimize this. Okay, so let me begin. Like I said. Okay, so I want to give quick intro of myself. Like Sitolosi covered fairly well based on my profile on LinkedIn. Currently working as a senior data scientist at VMware. I worked in Microsoft before, some experience working in the fintech, in the banking industry. Like I mentioned, I started my career itself with a data analyst. SPAWAR is a government entity here, ran by US government for Navy. It is based out of San Diego, California. So I worked as a data analyst there for Cyber Operation Command. So mostly doing the helping the SOC analyst with additional data analysis and investigation as needed. Later, I transitioned my career to data science. I went to school in the University of California, San Diego, to do the master's in data science, and I learned a lot from industry folks and school, and then I transitioned my career to data science. Obviously, tomorrow's talk will be more focused on the data science career, so I will talk about career transition paths based on my own experience, right? So I am also a US Army veteran. I have worked for 4 years from 2010 to 2014. Some of my things to do besides work is I love to travel. I have enjoyed watching soccer sports, like used to be part of playing, but now like I have a 1-year-old daughter and I'm mostly kind of like boxed to watching than playing, right? So, but I enjoy time with her. Today's agenda, I want to cover the what is big data. Like I mentioned, what are the tools and technologies for the big data and big data mining versus resources spent, right? So this is sometimes kind of like underlooked a topic because okay, we all see value behind the big data, and are we doing the accurate, uh, calculation of ROIs versus what is being, produced by big data for the company, so what I'm getting versus what I'm spending is also important, uh, and the major kind of focus will be big data in cyber, how we are using it, and what are some of the challenges, right? So uh, so imagine this situation. Let me begin with very practical situations. So it kind of resonates with our daily life, right? So uh, you just have a made a post in Facebook, right? You share a link with your friends and your family, and they are all liking it. They are sharing it. You just watched a video on the YouTube, uh, and then you share it with your friends who then watched the video and share again, right? So you made some shopping on Amazon or any other online portal. You just paid your phone bill online, so this is all live incidents, right? So I mean, you are watching the video in Zoom right now. We are kind of generating data, right? Every second, every minute. So I mean, these are very like normal examples, right, of an internet user that is generating the data. And imagine that these activities and even more activities are done by almost 5 billion people in the internet, right? So that's the daily average user on the internet, 4.95 billion, right? So, I mean, obviously we can imagine the volume of the data we generate, like how much data we generate and how much data the companies are consuming. And how are they going to use this data to produce the value behind it, right? So if the data is just sitting on the storage racks, like if we're only collecting data and cannot produce the real value behind it, in the industry, we call that data as a dark data, right? So we don't want to be in that space where, like retail industries, the example of Amazon, they use the data, all our transactions, all our user activities, our click-through rates, all these things for marketing, like recommendation, putting like how to productionalize the data, right? So from the data, so that is important. So this is just a glimpse that we generated data in a huge amount, and that's how the introduction of big data comes in play, right? So what is big data? So I took this definition right off the Gartner glossary. So big data is high volume, high velocity, and high variety information assets that demand cost-effective, innovative forms of information processing and enabling the enhanced insight, decision-making, and process automation. So I like this definition. There are many, obviously, but it covers the key aspects of it. I mean, obviously, I'll cover in more slides, like what are the different V's that defines the big data. But, like the major three are the volume, velocity, and variety. So like the volume of data itself, and then like velocity, how much data we are producing, and like varieties, different types of data, like structured, unstructured, semi-structured, right? Uh, so the other thing it covers is like the information processing, which is very important because raw data is now becoming the business insights, which is like data being processed is called information, right? And that information helps us for insight, full decision making. So that is like key aspects of this definition it covers, right? So here's the three V's, right? So three V's kind of makes a triangle here. uh, so the volume is size of data, like I mentioned. The variety is different types of data. And velocity is the rate that the data changes and the rate that data is being produced, right? One is like the data is being produced, and then the one is that data is being going through the ETL pipeline and changing its form, right? So like it's adding the attributes, it's getting pre-processed, it's feature engineered for machine learning, right? So all kinds of examples we can think of. And then that's how the different V's are. So like I said, the V's are evolving. So people keep adding like, okay, so to the definition of big data. And the other popular, like as the current industry trend today uh, I would say there's more. Obviously, I'll cover in next slide, but the I like to at least limit on the first three that it started the definition with. Actually, that covers quite a bit of the big data definition. Then like the other three as the veracity, the degree which the data can be trusted, the quality of data is what the veracity covers. The value is like what value it is producing for the business, right? And the variability is almost like variety, but this one is like how many ways you can format the data, reformat the data. So some of them are like kind of like, like adding on the same topic, but obviously the definitions is evolving. That's why like we see a lot of V's flowing for definition of big data. So I mean, there's more. Like I said, the volatility is data storage, how long we should store the data. I mean, big data is expensive, right? So as we generate more data, if the value is not behind it, that's why the value add or information processing matters. Are you generating enough value from the data? If not, then obviously you have a business policy to like retain for a certain amount of time and archive it or delete it, right? You don't want to kind of hold it, the data, unless the policy tells you. Then validity is data consistency again. Is the data being consistent today? Like we get in one form, are we getting in the same form, or is changing, right? I like the recent one that has been emerged with which is called visualization. And sometimes the big data is, like it's the patterns are or for the ML approaches, like when you do exploratory data analysis or when you produce the result, like the visualization matter at those two ends, right? You begin with exploration. That's when like you need to visualize your data. You can do through sampling to limit your data and visualize that point of time. But once you produce significant results, like you want to define your KPIs, the key performance indicators, your metrics, then you measure it, right? So how do you visualize it? How do you track it? How do you monitor it? So I kind of like this new trend of adding visualization to the big data, right? So can we visualize the patterns in the data? So the other slide that I have here is the timeline of big data evolution. So like I said, so I mean, it has been in the industry for a long time. It's not a new kind of like phenomena or something that happened right away or in the new century, right? So it has been going around. So this slide is just the timeline, what it covers, like how the data size is growing. The data size is exponentially growing. Like I think from 2010, the internet era, like kicked off with retail industries, like kind of like Amazon and other online portals, any other shopping portals like Shopify. They saw the market behind the big data. They saw the value behind it, and then like social media platforms, like like all other search engines like YouTube videos. If you look at it, they all are in the like early 2000s or in the mid 2000s of 2010. That's when it's kicking off. So in 2016 is what marks the zettabytes of data flowing, right? Like it was around like petabytes before, but now you are seeing massive amount of data flowing. And the only thing that is guaranteed is it's gonna keep growing on the exponential rate, right? It's not gonna slow down. The way that we have IoT's devices, the way we have, like, imagine the pandemic, right? So we all kind of like digitize how companies go digitization. The companies used to just go small companies on-site roles. Now every one of us like mostly working from home, right? So we kind of like generate additional data, additional, like on that. So I guess the train, just my message is it's gonna keep increasing than ever. So this is the slide kind of give a quick glimpse of how many verticals are there and how these verticals are related in a sequence when it comes to the data processing. So this slide kind of wants to cover about the tech tools and technologies, just giving, there's some just few names. I just didn't want it to put a specific name there, but like I have to put some, just like nothing from the marketing perspective, or I don't want anyone to just go learn Cassandra and no SQL database. So, but what I'm saying from here is like obviously want to have some tools as an example, right? So the data sources in the initial phase, obviously we know that companies using the like different ways to generate the data, their own ERP tools, CRM tools, and like their social media engagement, all the devices they have, there's some examples how data sources data is coming from. Then after your data sources, you have to acquire the data, you have to kind of like collect the data, right? So that it actually kicks off the ETL pipeline. And then the ETL kind of stands for extraction, transform, and load, right? So like kind of like in the data engineering term of how you get the data, transform it, and then reload it, right? So to the warehouse. So there's few tools popular. I myself a heavy Spark user, and then I like Spark because it also supports not only in the extraction processing, but it also supports in the analysis, where we kind of like use it to generate the features for machine learning, especially from that aspect. And then the data storage is like companies coming up with data warehouse concept, data lake. You hear all kinds of new industry term, where it's pretty much getting the data from multiple sources and integrating and putting in one location, rather than like trying to do analyze. In the analysis phase, you want to limit yourself to go and like retrieve the data from multiple locations. So that's the idea of warehousing. And then Cassandra is a NoSQL flavor of database. It kind of like works by keys and spaces. There's MongoDB is another one, popular one, which is document-based database. So obviously we have many for the relational world, right? And like when it comes to relational versus non-relational, my rule of thumb is, like if you have a non-structured data, right? It's like unstructured data, then obviously the relational database kind of like doesn't work efficiently, because at the max you can do is just have all as a string on a one field. But I mean, that might just like over limit, or cross the threshold right away. So this NoSQL databases is kind of designed for the uh, like the JSON format files, which is kind of semi-structured, they call it, or the other key value pairing. Our whole document can be one value you can store in the database. Then comes the data analysis phase, which is where the good thing happens, I would say, right? Like you kind of process the data to produce the value. So that's and most of the ML platform kind of like falls on that vertical. And then reporting and dashboarding, where you want to present the results. Like I mentioned before, the visualization. That's why I start liking the inclusion of V for visualization in the big data definition. So big data mining versus the resources cost, right? So I kind of touched upon in the intro slide a little bit. Let me extend it. So big data can produce value, but it's not cheap. That's kind of like a one way to look at it. Most of the machine learning algorithms need big data for pattern recognition and predictive modeling. So there is a value definitely behind it, because like the today's uh, uh, era of using advanced deep learning models, neural nets, they actually rely heavily on the data. So for them to learn and perform well, you have to have massive amount of data, right? So when the competitions like image recognition came in play, uh, the convolution neural network CNN models, they actually the best part of their model was performance was the size of data that they can get, because the more images they look at it, for example, like cat versus dog, the thousands of images is not gonna produce a good results. Like you have to have kind of numbers in millions. So when you have a lot of images, then obviously your model start learning like the hidden patterns behind it, and then it will figure out what it is, right? So definitely a value for the advanced model that the size of data is adding, but there are associated costs with it, right? So the initial is the infrastructure cost, like we looked in the tools and technologies slide earlier. So you need to set up the data warehouse, you need to set up the ETL pipeline. These are just initial investment, right? Then human capital, I mean, the big data experts, or the people who can build that batch streaming, all kind of pipelines is not cheap. Like the talent, the skills, it's hard to find. One is hard to find, and another is not cheap, right? Then the management and maintenance cost, then like you cannot just build it, you have to just keep constantly monitoring it, maintain your pipeline, right? So, and there's obviously other cost, like data storage, networking, queuing, like today we go from on-prem to cloud industry, but the cloud industry is like it puts everything on like like you consume and you pay kind of model, pay as you go model. But I mean, the costs are there for everything pretty much. Like even if your machine is staying idle, but you have it on, I mean, it's kind of like getting some storage and you're paying something, right? So what I'm trying to say here is the evolution of the era from on-prem to cloud, or whatever the technology we are using, we can build our own, but all it takes is a massive amount of cost. So it's always good to do that exercise in the beginning, like what is your big data kind of like situation, what are your forward leaning, like a use of the big data. Are you building machine learning models? Do you have a use cases to do it? Do you have a use cases to produce it? The value behind it, right? So you always can build a small proof of concept or MVP to start with, and then do the parallel cost mapping. Like some companies, small companies or a startup I have seen, obviously do over kind of like estimate the value they can produce from the data, and then what they found out is like they cannot manage on the cost side, right? So it is really important. So let's cover our main ground here, which is big data in cyber industry, right? So obviously analytics is not new for security. We have intrusion detection system or fraud detection system for a long time. They have been working good for some time, and we still use it. Like, the heuristic based or signature based models are still there. So what is new? What is the big data is adding? What were some limitations without big data, and what is the big data is adding, right? So let's see. So one is the storage, obviously. Before the structured data was the one we have tables in normalized forms, all the tables in the relational world, right? It adds some limitations because you cannot, like, for the pattern recognition or something, like, you have to build the relational like you have to have the additional aspect of, like, nodes and vertex, especially in the cyber industry. Like, if the device is connecting to the server is connecting to another servers, and then user is kind of like doing all activities with multiple database servers. If you kind of try to visualize the same thing on the relational world versus the graph world, I mean, the graph world will definitely add you value. There's additional algorithms you can use from the graph side, because in the graph world, like, once you have, okay, for the same example, a user simply his activity, daily activity, right? You log in, do his work. uh, that's normal behavior. So in order to us to identify the abnormal behavior there, if we just do from the relational world, you cannot see some of the patterns like the user is doing. For example, user's credential is hacked. So I mean, when the credential is hacked, the hacker or adversary, they can kind of like get into the systems because they already have the credentials, right? But to mimic or like replicate the same activity, that's when the user behavior analysis or UBA industry is going to replicate the same behavior, like the way that I kind of like interact with the systems. The maybe like that is hard to replicate. So what I'm saying is, like, my credentials can be hacked today, but when they log in, are they going to do the same activity that I'm doing? I mean, they cannot replicate the activity, because unless they have been tracking me for a while and kind of like doing the RPA, like, like process mapping, right? So the process that I've been spinning up, it's users behavior is hard to replicate. That's what I'm saying. And those kind of things, like, is the uh, is adds value for analysis and security, to do the behavior analysis, and then relational database kind of falls a little behind on that. Before, in the past, we only have offline or batch processing, because like, almost a near real time or streaming like processing. Like, today's world, the tools like Kafka, Kinesis, they do near real time processing, right? The reason I say near real time is, it's like, okay, it's always 5 to 10 minutes delay, no matter how fast is your pipeline. So in the past, like, for fraud detection example, for example, like, banks used to process the last 24 hours of transactions in one day, and then in a batch, and then they kind of flag this is fraud versus not. Today, I mean, like, it's almost like once you swipe the card, like, they have to run the model to detect it, right? So, and this possibility is only because of big data processing. And in the past, like, say, we only handle structured data, and today in big data world, we handle unstructured data, right? Like customer reviews, all the text data, all the unstructured data adds the value. So here's some common use cases of big data and security. So one is detection. I added there because everything starts with detection, right? So if we hear the tools, they're like, okay, detection and response, they call it. Obviously, preventions, detection and response, right? So those are the key terms you hear in cyber. And like I said, the examples are intrusion detection system that has been going around for a while. But what is the advancement? What is the new ML based approaches added there? So those are some of the value that big data can bring in the security, right? So anomaly detection, we need a huge data, obviously, because you have to first define your normal baseline. What is user doing in a normal days, right? Like, what is all the machines behaving in a normal way? you need to find out your normal kind of like decision boundary first, right? Then only like you can say, okay, something is kind of deviating from the normal. So when you say something is deviating from the normal, you have to define your normal first, right? So which is kind of like hard to define the baseline. And then the big data kind of adds value, because the more data you have, then you can kind of do more pattern recognition. You can apply clustering mechanisms or any other supervised, non-supervised, depending on the labels of data you have or not. Then it's easier. Like the what I'm saying is like big data is adding the value here. The alerts classification for your SOC or threat analyst, right? Security Operations Centers is what SOC stands for. And then they kind of like gets the alerts to go through every day on a daily basis. How can we optimize that list for them? Like how can we say drop the false positives for them? I mean, burning their resources coming in daily and then just marking them as false positive is not added value, right? And big data help us to build some model to kind of detect those things. Malware detections, phishing, spam, email detections. There's a ton of use cases for detection side. And the fraud space, especially most popular in fintech, in my experience when I was working for Wells Fargo, the one challenge for the fraud space is, especially for bankings, and then the trade-off of false positive versus the false negative rate is a very important trade-off, because the customer satisfaction is like their number one, like the priority. I mean, if my card is rejected today, I mean, I have other options, right? And I mean, one time I can deal with it. For example, for the genuine, I'm a genuine user. I miss my own card, right? I swipe it in different zip code. I mean, it shouldn't reject it because I'm still the owner. I still have the card, right? So that's the customer's mentality. But if the model detect that, hey, there's a switch, this user has never moved to this state, and then he's swiping the card in different state, and then the model kind of like, rejected the transaction. I mean, it's for safety, I can take it one time, but if it happens multiple times, I have more options. I have more banks to go, right? So, I mean, customer satisfaction is always key. But at the same time, you want to make sure that you're not being more, your model is not being more flexible, that the real fraud comes undetected, right? So you have to, it's really hard to in the fraud space to detect that, the trade-off boundary, right? Uh, Incident response is like I mentioned, is for the, especially for the threat hunting team. uh, in the incident response here, we already assume that the breach happened, or someone is already in the network, right? What you can detect after post breach, right? So that is also valuable, because sometimes if you look in the, I mean, obviously in this, in the cyber, there's the cyber kill chain, right? So what is like, they have to, adversary have to get in the network first. They do this recon to get the information about the network first, then exploit, and then the last stage is only when they want to do exfiltrate the data. And then the state before that would be like, command and control. Like they have to sit in our systems, have the privileged access to everything. They can encrypt our data for a ransomware attack, or they can exfiltrate the data, right? So the end goal is kind of like, it's always data, right? So, but the incident response team, if they have a better tools, and then if we have a model to detect the anomaly, or like something fishy in the beginning of the kill chain, then we know like we can stop something bad from happening, even if they are in the system is only the first stage, and there's very less damage they can do when they are in the primitive stage than the later stage, right? So that's when the big data is useful, if you can detect and then response as well. So let's cover each areas, right? So big data in detection. APTs, obviously advanced persistent threat, right? Why they are called persistent? Because they can I stay on your system for a time. There was one survey, it says like on average it takes like 190 days for a company to detect that they are compromised. I mean, which is scary, right? Because until that point of time, you don't even know like someone is already in your network, or like the APT, the reason they are called dangerous is because they operate on a very low profile and very slow mode. So they like to hide as much as possible. They want to get as much information compromised as they can, as much systems as they can. And then, like I mentioned in the cyber kill chain, they want to stay until the end game of either encrypting the data or exfiltrating the data, or, kind of like causing some sort of trouble. But before that, they have a journey. They have their own journey, right? So adversaries have to figure out how they can, what are the most critical systems. They have to identify that. What is the database servers? What are some of the kind of like policies or security hidden behind those database servers, so they can kind of like act as a normal user. If they compromised one of the user's credentials, they want to act as a normal user to do kind of regular based transactions. And then later they want to kind of like you know prove themselves as like they take the max off in that's what the security world says, right? Event logs. Big data analytics is giving the opportunity for extended detection and response. I mean, today's in the cyber world, if you're following the trend, like they're talking about XDR. What is XDR? I mean, it's nothing new, but it's kind of like correlating multiple data sets you have in one place. So it's kind of like analysis model, actually. You get the network data and the application data. You are doing analyzing it separately, right? At the application layer or the network layer. Can we combine? Can we correlate this data and then kind of come up with a better picture, or like better decision making factors? That's what is XDR, all it is. So then behavior analysis, like I touched upon before, user entity behavior analysis is being huge. User behavior is like from user's perspective, like what a user is doing. If you build a user's profile, entity is obviously device, your servers, service accounts, things like that. Anything besides user is entity, and then their behavior is also important to track. Anomaly detection is huge. It's mostly the machine learning models is where it belongs to. And then big data in fraud, like I said before, trade-off is huge. Like I already said example, right? So false positive and false negative. So that bank has to put a lot of effort on improving the accuracy of the model, which is about reducing the false positive, but at the same time they want to maintain a proper recall, because the recall is about the measuring of false negatives, right? So they don't want to compromise the security for the fraud. At the same time, they have to maintain the high accuracy, because customer, I mean, they get frustrated pretty quick. Like if you are just kind of like notifying them with false positives and blocking their cards or rejecting their credit cards. I mean, if I have a good credit and then all my payment history is good, and if I get rejected, they better be like explain like why they rejected, right? So it's hard. Like that's why in banking, in my experience when I worked with them, the model explainability, right? So like we cannot use complex deep neural network and say, hey, I predicted this for you. I mean, my model says I'm not able to give you the credit card. I mean, that's not going to fly in the banking world. Like you have to explain why you rejected it. Like there are some features you cannot use because of policies, right? So there's many things when it comes to regulations and compliance with the bank. And then some of this data are going to be useful for them to improve the accuracy, like device profile. Like, okay, so user's device profile, if you build it, what is the okay, so we are collecting the data from the mobile app, right? For example, banking app, collect some data. Okay, so the like their movement, their other use of applications, what are they doing, right? Users profile, users behavior, and how do you map the user to device? For example, I have multiple phones. I should not be blocked in a different phone if it is same user, right? So you have to have that mapping. Geolocation data is important. So like how, if the user is traveling, for example, the same example I talked before. So if I'm traveling, and then if the bank has a capability of big data to collect other travel information of me, or kind of like get those information. And if they say, okay, this user is traveling, I mean, I can see he bought a flight from the same car, for example. It doesn't have to be same car actually, but if it is the same car, it's obviously obvious. And then they see that I purchased a ticket flying from here to Chicago, for example. Then when I go swipe my car in Chicago, their model should identify that this user has a travel history. I mean, he bought a ticket from our same car, so the car shouldn't be blocked. So that's the power of big data, because you have to like now track like a lot of other information and try to correlate these things, right? So that's how the model should behave. The IP data, users demographic. I mean, obviously, like the person who is in the fashion designer, if their job title is, they are more likely to be attacked by the phishing than the person who is using in security industry. Like person who is working in security industry, like their job title is security analyst. I mean, obviously the chances are less that they will be targeted by phishing attack, because they know like some links are fraudulent, like not to click, right? So those just example of demographic example. Then the travel history, like I mentioned, other data. I mean, there will be so many bullet points like this, like, and then how can we use those data to kind of like in the fraud space to improve the accuracy of the model is the key thing. And the other slide is the, like we say, three things was detection, fraud, and incident response, right? So incident response is where post-breach investigation, big data can help us to stop the APTs ahead of major damage, right? Like I said, in the cyber kill chain, they have to follow some kind of journey or path until they get to their end goal. Can we stop them ahead of time is the idea, and big data can help. Data enrichment. I mean, there's multiple datas. If we cannot correlate them, one simple alert sometimes can lead to the other events, right? So the way the malware analyst, or the threat analyst, the way they do their investigation is they always backtrack or reverse engineer, right? So big data can help on that analysis. Manage detection and response. I mean, just like XDR, MDR is another industry train. And what it is like for simple, small and mid-sized companies, you are not only selling the product, but you are also telling them that, hey, we help you fix it. We have our security experts to kind of guide you through how to resolve the alerts and issues, right? So it's providing the managed way of your own staff, like you sell the subscription based on, you can manage the alerts as well for them, right? So, and big data obviously helps on those kind of setup where you are helping your analyst to go through the investigation of the incidents. Now let's come to the challenges of big data and security. With all this talk, right? So the number one challenge, you can already probably see it, was privacy. I was talking about, hey, I have to track the user traveling from one point to another. I have to like get the information of his job title, right? It can help, but the challenge is the privacy, right? Privacy erosion is huge when it comes to big data, because now, like if today I'm like, sometimes it's kind of scary, because like, okay, you bought one thing, you watch one video, then it feels like there's non-intrusive way of companies or people tracking me, right? So they know like, okay, this might be a good purchase. Sometimes it's a funny thing that sometimes I just talk to my wife in the regular discussions on our living room about, hey, we should buy this and all, and then you see a ad on your phone about that. I'm like, oh wow, what is going on? So it's definitely scary, because maybe like your Alexa is hearing you, your whatever Google assistant is hearing you, or there's something in the settings you disable on your phone that I mean, it's kind of like when data is useful versus when it is kind of risky and scary when it comes from privacy, right? The other challenging thing is hackers also have the same advanced tools, and I would say they have more advanced tools, because they also have advantage of disguising and playing hiding, right? So I mean, most of the information that the companies, or at least from the defense side, what we can do is almost like some of the information is out there, right? So like, but for the hackers, adversaries, they always playing in the offense. They can get in once. Defenders, they have to get it right all the time, right? So I always say that that's the thing, right? That's a challenge. And data authentication integrity, right? So how much authentic this data is, like collecting all data from different sources. If are you collecting from random sources, like is it authentic data, or are they just synthesizing and fabricating the falsified data and selling you, right? There were few sites, like I don't want to call the name, but when we were relying on the third-party sources for additional data to kind of like augment, like, hey, can we detect the false URLs? For example, someone is visiting the URLs, is this URL scamming or something? Then sometimes the third-party vendors advertise that their data is kind of like valid and authenticate, but they use ML models, or they use generative models to generate data, right? So it's scary because if you cannot validate the data authenticity, then I mean, using that data is just you paying them money for just some fake data. So that actually covers my talk. And then I'm in LinkedIn. I put my contact info on the